Kubernetes, hosting mirrors with NixOS. Let's give him a round of applause.
Test. All right, hello everyone. So it's very nice to be here. So let's get started. This is our outline today. So primarily in 3 parts. So first, about me. Pretty brief, so you could look at that. I'm currently the president of our school's association on all tech things like JigPy. I'm also leading the school's Linux user group. I'm currently as the SRE role for our mirroring infrastructure at this school domain. I hosted the CEM meetup, so like in August 9th to 10th. So if you happen to be there, probably not. You might have seen me before. Yeah. So let's get started. So about our mirroring, what happens? So currently we have 2 machines. They all have Kubernetes enabled. One is called Milky Way, and the other is called Andromeda. The Milky Way is the service that provides public services, what you can access from the internet. It runs Debian Seed, which was Strixie, and now Forky. It accesses the Kubernetes control plane and worker node. This is the first machine. The other is Andromeda, which handles the storage. We have a ZFS reads that setup. It also runs Debian Seed, but it's only a worker node, not a control plane. And the third part is a in-house thinking backend we have. So we forked it from the Zhao University, which manages all the task life cycles. So like when to start, when to stop, what happens to retry, and all the kind of things. And it provides a RESTful API for the front end to query. Like when you open the site, it says like syncing is successful. Like when is it last synced? What's wrong? So the first part is about Kubernetes. Kubernetes, it's big, it's complex. There's a lot of new concepts to learn, like config map, there's service, there's namespaces, there's a path. And these itself are pretty hard to learn, but it also has a problem that Kubernetes is only suited for very large-scale deployments. Like 5 or 10 doesn't justify it. You would want like at least 100 or even 200. And also Kubernetes has a very complicated configuration in YAML, which is pretty bad. And so this is about Kubernetes. The next is about containers. Containers are impure. Like people might don't care, say that it works. It's kind of reproducible. It does the job. But containers are impure, and it's like not acceptable for us Nix people, right? And another part is containers have too much isolation. So our scenario, as I've introduced, is hosting a mirror website where our primary task is basically to just run rsync or a few git commands. And that is something that you don't really require that isolation, like separate network and namespaces. So that's like too much. And it's required by Kubernetes. So if we are to use Kubernetes, we cannot avoid containers. The next is about Debian Seed. Like all other operating systems besides NixOS, it's hard to keep track of state. And because we use Debian Seed, it's unstable, it's not tested. It's not like Arch Linux, which is still kind of stable and kind of tested. Debian Seed is not tested at all. And Debian has a bad documentation. Like, it's even worse than Nix. For Nix, it's like you have no documentation. For Debian, you have outdated documentation, which is even worse. It can be misleading, right? The next part is our in-house thinking backend. It tries to manage too much at a time. Like, it's a very long Go code, and the upstream is dead, so they are not using this. So we are now the upstream, and you don't want to maintain something that it's not what you wrote, right? So introducing Nix and NixOS. So Debian is impure, Kubernetes too complicated, so we just use NixOS. And instead of using our own backend, we just orchestrate with systemd services. And this also gives us the capability of a declarative configuration as the single source of truth. So you just look at the configuration and you know what happens. And since container provides too much isolation, we just don't use them. We use plain old systemd service. And the bonus is that we generate all the services from bindings from our configuration, which I'll show later. This last part is that our thinking backend is pretty huge. So we just don't do so much. We let systemd handle all the tasks, and we just query the status with its dbus API, which is pretty easy to use. So next, about how we actually implement this. So this is a pretty simplified overview of the entire thing. It's very simplified, so we don't have multiple files for a different portion. There's only default Unix for everything. So the first part is how we implement a WireGuard network. So this is basically the implementation. It's pretty short. I think it's less than like 30 or 40 lines. And the nice thing is that we just import this .nix file, which can be a JSON file if you want, and generate this configuration, which basically just use systemd networkd to set up the WireGuard configuration. And the good thing is that normally if you want to create this kind of thing, you need to remember to, like we're doing something like a full mesh. Like it's not exactly a full mesh, but it's kind of like, because we just filter out all the nodes beside our current one and set them up. So traditionally, if you want to do this kind of thing, you need to remember to update the keys every time you update nodes configuration, which is daunting and it's error prone, right? So this is our networking configuration, which basically is an attribute set of a list of nodes, and each node has this configuration about like what's its address, how to reach it. The next part is our syncing test, which is also pretty short. This is also simplified, so basically we just have a list of files that contains the test, and we just generate a systemd service for each one of those. We have this the data mirrors, which is our syncing directory under a ZFS reset pool, and your file is looking like this. So it's pretty simple. It basically is the start at is for systemd calendar, specifies how often to run, and this is a script you run. That's enough isolation for us. We don't need Docker containers. We just use this. And the last part is our Rust package, which is this is the syncing backend. So Nix has done a lot of hand folding, so it's very simple for us. We just use build Rust package and one lines of cargo hash, and it works. And we have this. This is the main program. We use Rust and Tokyo with Axum for providing HTTP service. We have this summary endpoint. It's a get endpoint that returns a status of the service with a schema predefined and compatible to our old implementation. And we just listen to this port. And this is like the core part that provides the service. So we use dbus that has a process macro to generate a proxy for like your debug interface. And you have this global connection state in storing as an app state, and you access the connection to connect to this, find this unit, convert it to a service, and you just query like, what's its last syncing result? You just check the exit status. When did it last finish? You check exit timestamp. And if you want to know exactly when, you can use Chrono to convert it into a familiar time zone, like Sun, June, like 23 or something. And the last part is like you want to know that has the syncing finished or not. So you could see to check for active state to see like if it's active or inactive, like starting or something. The last part. So what you have lost is the zero downtime updates and high availability provided by Kubernetes, because Kubernetes is like I start a new deployment, but the old is not purged, and it's only kicked in until the new is ready. But our thing is like you just let systemd restart the service, so you can't stop. But our school network is pretty bad. There's are occasional, or should I say frequent, downtimes. Like last month, I believe, we have like at least a dozen of times where each downtime is like 15 minutes or even over an hour. And the recent 2 weeks is like totally down. Like in every consecutive 24 hours, there's only like 2 to 3 hours where it's available. So our SLA is only have 3 nights or even less. Or you could argue that like 0.9% is also 1 night, right? Another thing is about scalability and other good cluster features of Kubernetes, like auto-scaling, etc. But we only have 2 machines, so it's not really useful because we don't use them. And the third thing is that our existing distro knowledge will not be applicable. Like, if you use Arch, you could say that I have this very magical file in /etc, and if you edit that, you can achieve what you want. But in Nix, it's pretty hard, and almost everything is configured exclusively through Nix. So you need to try to look up in Nix documentation, which is pretty lacking, and try to find what you want, or just read Arch wiki to find what you actually want to do. But the good thing is I've been promoting Nix and NixOS among my colleagues, and I can say that most people are using Nix or NixOS or NixDarwin right now. So we do have a big user base that they actually know Nix, so they can take over the maintenance. Now about the pros is that we have stable rolling updates. So Debian is stable, but Debian is not stable. It's kind of rolling. Like, it doesn't remove the old package, but it's not tested. And Arch Linux is not stable, but rolling. NixOS is stable and rolling, so we want that. And also, it has easy rollbacks. Like, you can just say NixOS rebuild switch rollback. But with other operating systems, with other distros, you want to say, like, we have a BTRFS snapshot or something with sub-volumes. But with Nix, you just switch to a previous generation. And also, we have unified and declarative configuration. So everything is in Nix, and you can share them across different configuration languages. For example, systemd has its own like INI-like format, and WireGuard has its own INI-like format. They're not the same format, so if you just use the two languages directly, you cannot share config. But if you use Nix, then Nix acts like a middleware between, like a bridge between the two languages, so it can share. And we also have code as documentation because Nix has an interesting feature that, like, if you just take a look at a brand new Nix code, you kind of understand what it's doing, but you cannot explain until you actually spend some time on it to understand. So this means that if someone is pretty new to our infrastructure, he can just understand basic idea of what happens just by looking at the source code. And then we can have our staff help him to learn more about the details. The last part is we have a lower maintenance cost. So previously we said that our thanking backend is forked from a upstream that don't maintenance them now. So our new backend is much smaller. It has only like 100 or 200 lines of code, so it's easier to maintain. And also the entire thing, like entire Nixing is declarative, and you have single source of truth. So you never like I need to SSH into the server to find out what is our current state. We just look into the Nix. And deployment are simpler, and you just say use nh or NixOS rebuild, so it does that for you. What is our takeaway? So Kubernetes is not a silver bullet. Like I've heard ideas that Kubernetes, like you have like 5 or 6 machines, you should use Kubernetes, but that's not true. Especially if you don't have many nodes, you're just asking for trouble. Like you would spend a lot of time setting up Kubernetes, and you just don't have time to do actual work. The next part is that Nix and NixOS is not that hard. I've come across this word before called JSON++. I think it's pretty adequate for Nix because most of the time what we wrote, like it's just JSON with a bizarre taste and perhaps with some packages functions. But other than that, it's just plain old JSON. And if you really hate Nix syntax, you could just say that I have a JSON file and just import JSON read file and use that everywhere. So that's also kind of acceptable. And you don't really need to know functional programming to use Nix. Like, you don't need to know what is a monad. Like, that is not required. And the last part is that documentation is very important. So our old infrastructure has little to no documentation, but the newer one has Nix. Like, the code itself is documentation, and we also have additional documentation on like how you could get started to the entire Nix thing and how you could deploy with that. Right. So some acknowledgement. I came across to Xidian University like last month, and I learned that they have already implemented this systemd service kind of thing, but they were in Python, and I take some inspiration from it, and that was a nice implementation, but it's not public, so it's shared privately. The next thing is to thank for SamuDR. He has this nice background image. So there's a light one, there's also a dark one. I think you have seen this today, like morning in the aula. But I've used this throughout this slide and also as my own Mac's wallpaper. Yeah, so that concludes it. Wait, I have another thing, anecdote. I have an anecdote to share. So about this. So why I say Kubernetes is hard? So, okay, time is 4 minutes. So one thing is that our old configuration, like our mirroring frontend uses Nginx, and like I think 2 years ago, one of our previous maintainers want to add broadly compression to Nginx so we could serve compressed assets. But our Nginx config is stored in a config map. So you know that if you want to update that, the service uses the config map. So whenever you change the file, you need to sync it into the config maps and then restart deployment. And what we have is that everyone just modifies the config file. None of them synced into the config map. So we were always using the old configuration for 2 years. And when I changed the config map and switch, it kind of broke because our Nginx image doesn't have broadly support. And since no one used the new config map, they never realized this. So that's kind of a reason why we don't want Kubernetes. Yeah, so that concludes. Yeah, any questions? Yes?
I was wondering, when you were building up this new system,
Sorry, can you repeat that in the microphone?
Sorry, of course. When you were setting up this new system, what other, I guess, software systems did you consider? Like, for me, Ansible comes to mind, but I was wondering what you might have thought of alongside NixOS, or did you just jump into NixOS right away, or did you try other things?
You mean alternatives to NixOS, the entire solution?
Yes.
I've briefly considered Terraform, but I think their language is even worse than Nix. So, like, I know Nix is different from Ansible and other systems because Nix itself is a problem. Like, you have software dependence and all the Nix store issue. But I'm fairly acquainted with Nix, and I don't know much about Terraform, Ansible, or other solutions, so I thought it's probably better to just use NixOS. And also, I'm basically the only person who is maintaining, who is caring about this thing, so I have the final say. Yeah. Anyone else? Yes?
Do you know who set those 2 machines up with Kubernetes and why?
We used to have 3 machines, and they decided to use Kubernetes. I know it doesn't justify it. I have no idea what they thought at the time.
And did you ever have to do a Kubernetes version upgrade?
No. And, you know, I can say that I don't think anyone from our team knows how to do that, so we just use the old one. It works. Yeah.
Yep. Thanks for the insights.
So you could give the, yeah.
I have sort of a bizarre question. So you set up a WireGuard, right?
Yeah.
So if you have 2 machines, why do you need the VPN?
Right. So there is a problem that if we do have some service that has to be run in a Docker container, and we use OCI containers to set them up, right? But if you want to publish a port, it bypasses all the firewall rules. So everyone from like the local school network can access it, which is not what you want. So what we can do is that we have this network, and we publish the port to the WireGuard IP. So you cannot exit from outside.
Yeah, you can manage firewall rules manually, so to say. So you don't say open port in this OCI configuration. I forgot what it's called. You don't specify the port there. Instead, you just write IP tables commands. There is a way you can Google that if you want. So and I mean that's at least what I'm using, and that's pretty easy, and it works, and it doesn't require VPN. I was just curious about VPN. That's it.
I try to avoid using like NAT tables or IP tables. Because if you know, I happen to have a firewall D Nix project, so I try to avoid those low-level things. And also, we have this, we have two machines, that one for storage, another for public service. So we have this NFS share. So it's also pretty better to if could limit the access to that WireGuard IP range, CIDR, right? So that would be useful.
Okay, I'm not sure if we have more time left. Yeah.
Yeah. So
I'm gonna have to cut it off. So let's thank our speaker again.